but I'm asking you to find the area of that first one there in part A. No, that is not a trapezoid. If you quickly look at it, it may look like one, but count the number of sides. There's 5 sides there. That's not a trapezoid. In fact, it's a figure we are unfamiliar with. But it can be broken into figures we are familiar with and have formulas for. Maybe I think in elementary school or middle school, you might have called these irregular shapes, right, where you cut it up into figures you're familiar with. I call them composite figures. These to me are composite figures. All right, a figure that can be broken down into polygons that we do know. So take a look at this first one. I'm not going to do the next two with you. Those are going to be done in your group. But on this one right here, you could definitely draw in a vertical or a horizontal line. So you figure out which one you want to draw in, and somebody's going to give us a class direction here. All right, what type of line you want to draw in to break this up into whatever, how many? Gabby, what line you want to draw in?
8 down to.
Yep, little vertical line here. That's what everyone's been doing. Now look, if you decided to do this one right here, this horizontal line, keep going. Try to do it. You should come out with the same answer as us. Now, is there a requirement that you only can draw in one line? No, you draw in as many as it takes. We could draw, take a look, we could draw in this vertical line coming down and now have 3 figures, which we're familiar with. All right, so it's not a requirement that it has to be one and only one. So let me go back to Gabby's vertical line. All right, when you draw that vertical line in, I'm going to do the same thing I did yesterday with you. We end up with a rectangle plus a trapezoid. I don't require that you write this, but I like doing this. It forces us to write the formula every time. Length times width plus 1/2 the height, and then you guys know, add your bases together. All right, let's start with the rectangle. What are the length and width of the rectangle here for me? Length and width. Gabby, back to you. 8 and 12. Good work. 8 times 12. That takes care of the rectangle. Let's go to the bases. What are the bases of the trapezoid? I'll get to height in a second. Bases, Josh, what are my bases on this trapezoid?
12 and 5.
Okay, I understand how you got 5 because it's literally written on there. How'd you get 12?
Because it's like written, and you can just move it over since it's a rectangle.
That's what I was looking for. Rectangle, opposite sides congruent, so that's got to be 12. Good. Now the height. Could you draw the height in? You could, but also remember the height's right here too. Vertice, perpendicular to the opposite side. The height is right there. You don't have to draw in another one, but if you did, they're both going to be the same height, which is, what's the length of that height? Oh, 8 and 7. Explain to us.
15 minus 8 is 7.
There you go. Opposite sides congruent, so that's 8. And Aiden's in honors math because he can subtract, and that gives him 7. Here we go. Round to the nearest tenth if necessary. Well, it's not here because it does come out to be the nearest tenth. And nearest tenth, what are we looking at there? Kisnia, what do you have?
155.5.
$1.55.5. Next week, half a point off every time if I don't see them. Inches squared. So I know we're doing the area, not perimeter or any other way. Questions? Okay, you're going to do B and C in your group. Go to part D for me now. Go to part D. So we had the irregular polygons that we can break up into figures we do know. Second type of problem you're going to see today, shaded region. Find the area of a shaded region where I can't break it up into figures I'm familiar with. It's not going to happen, which is the case right here in question D. Find the area of that shaded region, NVATH. You will not be able to break that. Even if you can break it up, I don't think you need the value. You're not going to find the values you need. So let's just talk quickly how to find my go-to on how to find a shaded region. Pretty easy. It's not a formula. It's just, hey, let's find the area of the whole thing. Find the area of the whole thing, which is a figure we should be familiar with. And then we're going to subtract out the non-shaded part, aka the unshaded. So then we'll subtract out the area of the unshaded. So it's the whole thing minus the unshaded. Real quick so I can write it in words. What is the whole figure? The whole figure. Olivia, what's the whole figure here? That's a rectangle. Yep. So I'll do rectangle minus what's the unshaded figure? The whole thing, the unshaded figure. Zoe? Triangle, yeah. All right, so that's how we're going to get that shaded figure. Rectangle from the last problem, length times width. Triangle, 1/2, base times height from the formula sheet. If you haven't done so already, go ahead and label your diagram. All right, what's the length and width of my whole rectangle here? The rectangle has a length and width of, Zoe? Yep, 15 and 6. Multiply those. Do not take this as two separate right triangles. Take it as one whole triangle. So I'm talking about triangle MBA here. Triangle MBA, I want to subtract its area from the rectangle. So what's the base and the height of triangle MBA? Where are we going there? Christina, over to you.
The base is 15 and
Yep.
the height is 4.6.
Got it. I don't know if I stressed this enough. The base can be any side, but since the height of 4.6 is drawn to MA, I'm going to consider MA as my base. But it could have been any side, but the height's drawn to the base. So that's how I'm going to find my shaded region. And we have a shaded region of 55.5. All right, in your groups right now, you have parts B, C, and E. I'm going to write those answers up on the board here. If for some reason you and your group get stuck, please call me over. I will help you out. If you get through B, C, and E, no issues, answers are correct, keep going in the packet to the assignment. And answers are right up here now.